Okay, so opening this bad boy up, I got the screw terminal block mounted right here, and I put an inline fuse holder, 10 amps. That goes to the, it's a little hard to see here, but this is the battery switch, right? So I have a way of turning the power completely on and off on this. So from there, the output of that switch goes into the splice here, where when the switch is flipped, it'll send battery power to the DLC connector. So any device plugged in here will work. And it also sends it to the 5-pin PCM connector I built here. I also have a jumper that goes to feed the ignition switch. So this is going to be the switch you use really when you're cycling the key, if you will, during flash programming. That's how I'm going to do that, is with this switch here. And the ignition switched power only goes to the PCM connector. There's no switched power at the DLC connectors, even from the factory on these. You can see my ground block, so this worked out pretty well. I got one ground going to the PCM, the grounds for each LED in the switch, the main ground from the AC adapter screw terminal block, and there's two grounds that go to the DLC connector. So why to use white wire here? Because they ran out of black. So whatever. I used twisted pair wire for the CAN low and high, going from DLC connector to the terminating resistors, and then from the PCM connector to the terminating resistors. So all I did was twist two pieces of wire around. It's really nothing fancy. This kind of length, you probably don't need to do that, but when you're talking about potentially bricking a $1,000 PCM during flash programming, I don't want to take any chances. So I twist wired it anyways. Trying to get a better view of this. Not very easy to see here. Let's see if I can focus. Come on. Yeah, that's probably as good as it's going to get. So, oh, there we go. So on this solderable breadboard, I have two, you can see on the very ends there, 120 ohm resistors. And these rows are all interlinked underneath. You can't see it from the top, but they're interlinked, so it makes it really easy to add these two legs. Because the way this works is, at each end of a CAN bus, you need to have a 60 ohm resistor, and that's to prevent signal reflection and noise in the circuit. In between those two resistors, regardless of how long this circuit is where you're going to connect your twisted pair wiring. So you can see on each side of the resistor, I have color-coded just so it's easy, but it doesn't really matter. You have your CAN low and your CAN high. So, worked out really easy. This actually worked better than I thought it would. So you can see I just soldered it right in, and we're good to go here. One big thing to make sure this works is when you measure the resistance. I mean, technically you do it with the PCM connector too, but it's easy to do it here too. I did it both. 6 and 14, your two CAN pins, you should measure 60 ohms. If you only measure 120 ohms, you didn't wire the resistors up right, because when they're in parallel, you'll have exactly 60 ohms, or very close to, I shouldn't say exact. So I already plugged in a Bluetooth DLC dongle, and that worked okay. So tomorrow, once my PCM connector and terminals arrive, I'm going to wire that up, and then I'll plug it into my PCM and confirm it talks and nothing lets the magic smoke out of the box. So that's it. It's not pretty, but it's quick, it's sturdy, it's easy, and again, I built this for $110 within an hour, and I have enough supplies I could almost build 2 to 5 of these if I had cases. So quick and dirty. This does everything any other bench flash programming module is going to do too. So that's really all it is. So take it or leave it. You can spend $700 if you want, or you can build one of these pretty easily.